Hello, welcome back. This is now 4.1, and we are working with systems of linear equations. So what exactly is a system of linear equations? Well, it's going to be a set of two equations. So on the right, you see problem one. You have this weird bracket-looking thing, and then you have 7x plus 6y equals -4, and then 6x minus 6y equals 30. Okay, so the bracket thing right there, that's just a way of grouping these two equations together. It's like, hey, look at these. We're going to consider these guys a pair. That's what we're analyzing. So they put the bracket in front. Don't overthink it. It's just some notation. And what exactly are we doing with these? Well, we're looking for visually, we're looking for where they hit each other, okay, where they intersect. So you can imagine if I were to take the time to graph these, each would represent a line in the plane, and then there would be some point where they would hit each other. Okay, I mean, there's cases where they won't hit each other if they're parallel, but let's just pretend that they do hit each other in this case. And so there's going to be this intersection point, and that is going to be the solution. Where do these lines hit each other, basically? Okay, in the beginning, what they're going to do is just give you an ordered pair, and you have to kind of check to see whether it's a solution or not. This is helpful because if you are drawing the graphs your own without the computer, you are liable to not know exactly where the point is, right? So maybe it's in between some tick marks and you need to make sure that you got the right answer. So you take that solution and check it. So basically it's checking solutions here. And okay, so let's try number one. They're giving you the point 2, -3. And what you're going to do is plug that number into each of the equations. And if both equations result in true statements, then it is a solution. Okay, so the first guy, 7x plus 6y is -4. So this is x, this is y. So plugging 2 in for x, I'll have 7 times 2 plus 6 times -3 is -4. So this will be 14 minus 18. Okay, and that will be -4. So the first, the point is definitely on the first line. Okay, so that's good. Wait a second. Okay, but it needs to work in both equations for it to be a solution. So if it's okay, so let's look at the other equation. 6x minus 6y is 30. Again, plug in the point. So 6 times 2 minus 6 times -3. So we got 12 plus 18. And again, that one works. So both statements are true. So that tells me this thing is a solution. This ordered pair is a solution of the system. Okay. So you would type in or hit the little circle for 2. Okay, question 2, we have some fractions to deal with. No big deal though. I'm going to get the equations. I'm just going to write them kind of however I want to put them. So I'm going to put them x plus 4y, and then next to it 5x plus 4y. And I'm checking the ordered pair 3/4, 1/16. Okay, so this is my x, this is my y. So 3/4, plugging into the first equation, 3/4 plus 4 times 1/16 equals 1. So that will be 3/4 plus 4/16. 4/16 is the same as 1/4, so that would be 1/4. 3/4 plus 1/4, add the numerators of the common denominator. So 1 is 1. So that one works, but I need both of them to work for this to be a solution. So we go to the other point, or the other equation. This will be 5 times 3/4 plus 4 times 1/16. So the first guy, 5 times 3 is 15, over 1 times 4 is 4. And then 4 over 16 is the same as 1 over 4, so that would be 1/4. So we have 16/4 equals 4, and yeah, that's true as well. Okay. So this guy is a solution. Okay, so you just go over there and click on the ordered pair is a solution. And good. Okay. So more of the same. You're just plugging and chugging away. I put some decimals in this one, no big deal though. I guess we can try that if we want. So what is this, number 4? X minus 2y is 400. And then 0.04x plus 0.02y equals 66. And we're checking the point 1400, comma 500. Okay, so plugging in, this is my x, this is my y. So I have 1400 minus 1000 is 400, so that one works. And over here, 0.04 times 1400 plus 0.02 times 500. I'm going to have to go to my calculator. So, clear 1400 times 0.04 is 56 plus 0.02 times 500 is 10. So it looks like this one works. So I'm getting really lucky. All the ones I've looked at so far have worked. So that's a solution. Clearly, they're not all going to work. Okay, so almost like forced to do one that doesn't work. Let's see if this one works. 6, yeah, that one's not going to work. Okay, so let's try 5. 4x minus 3y is 27, and then 2y equals 3x plus 1. The ordered pair is 9, 3. This is my x, this is my y. So I have 4 times x, which is 9, minus 3 times 3 is 27. So I got 36 minus 9. 27, that one works. But both have to work. If either one is a false, if they're both false, it's definitely not going to work. But if either one is false, then it's not going to work. Okay, so let's see this one. 2 times 3 is 6, and then I have 3 times 9 plus 1. So 6 is 27 plus 1, so 6 is, finally I found one that didn't work. So this is not a solution. Okay. So the ordered pair is not a solution. Okay, so from that point, you're stuck with graphing equations and looking for the solution. So in the first set of problems, they're giving you a potential solution. You're just checking to see if it is a solution. Now you're actually plotting the lines and seeing if they intersect. And if they do intersect, then that is the solution of the system. Okay. You can use whatever method you want to plot the lines. So for example, in 6, it's best to use the x and y intercepts. Let's try number 7. So I have x plus y is 5, and then y minus x is 7. So for the first line, x plus y is 5. I'm going to use the x and y intercept, all right? So if you want to, you can do it as a table. So for the x-intercept, let y be 0. For the y-intercept, let x be 0. So when y is 0, you get x is 5. And then when x is 0, you get y is 5. So I'm going to plot this on, well, okay, I'll plot it in 2, 3, 4, 5. Now, for this, when you're doing it by hand, you need to be a little bit more careful than probably what we've done in the past, because you're looking for where the two lines hit each other, and it might not be 100% clear if your graph looks like junk. Okay. Let's get the other guy. Y minus x equals 7. So when y is 0, x will be -7. And then when x is 0, y will be +7. 5, 6, 7, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay, so there's our points, and then we're just connecting the dots. And I mean, you could kind of guess that they're not going to be fractions in your ordered pairs, but it looks like maybe it's at 1 or 2. So I'll just say 1, comma, 1, 2, 3, 4, and it's a -1. 1, 2, 3, 4, 5, 6 maybe, -1, 6. And then if you don't have the graph paper, and I promise to put graph paper on the next test, so it's a little easier. But if you don't have graph paper, you're kind of stuck with your methods from above, where you're checking your solution. So you could plug it into both equations. So x plus y is 5. So this is my x, this is my y. It'll be -1 plus 6 is 5. So that one works. And then for the other guy, it'll be 6 minus -1 equals 7. So 6 plus 1 is 7 equals 7. So that one works. So that's the solution. In the software, it's a lot easier. So let's go ahead and plot these. So it'd be 5, and then 5, and then for the other guy, it's -7 and then +7. And then you can clearly kind of read it off of the graph. So from this point on, I'm going to be plotting on the software as opposed to plotting it by hand, just because it's so much easier. So it's -1, 6, I think is clearly seen now. Okay. Yay. All right. So a general rule of thumb is that if your graph is in the form of ax plus by equals c, so I don't want to say graph, but your equation, then you want to use intercepts to graph the thing. Right. If your equation then is in the form y equals mx plus b, then clearly use the slope and the y-intercept. Okay, so if you wonder, which method am I going to, I mean, you can use whatever method you want, honestly, but it's less work if you do it this way. So in problem 8, you're going to be using the x and y intercepts. Problem 9, use the x and y intercepts. Problem 10, then you're going to slope and y-intercept. Okay. So let's try number 9, and then we'll go on to the other type. So I'm going to write out my lines, my equations, not with these on top of each other. I'm going to write them out like this. It's a little easier to kind of do the work I need underneath them. So for the first guy, the x-intercept, you let y equals 0. So I have 5x is 5, and then x is 1. So I get the order pair 1, 0. And then for the y-intercept, you let x equals 0. So I'll have 5 times 0 plus y is 5. So y is 5. So 0, 5. Then go to my other equation. For the x-intercept, let y be 0. So you get 2x minus 0 is 2. And then x is 1. So I have 1, 0. And then for the y-intercept, let x be 0. So I have 0 minus y would just be minus y is 2. So y is negative 2. So I have 0, negative 2. And then I'm just going to go ahead and plot it here in the software, because it's so much nicer. So 1, 0, and then 0, 5. And then 1, 0. So we already have the intercept if you're paying attention. 1, 0, and then 0, negative 2. Okay. And then the solution, the place where they're hitting each other, is 1, 0. So you could literally get it just from the intercepts in this case. Okay. So problem 10, then you see the equations are in the second form, the y equals mx plus b form. So in that case, just go ahead and use the slope and the intercepts to get your graphs. I'll go ahead and write out the intel. And so we have y is x plus 4, and then y is negative x minus 4. So the slope for the first one is 1. That means go up 1 over 1. And then the y-intercept is a starting place, that's 0, 4. And the second equation, negative 1, so I rewrite that as negative 1 over 1. That means go down 1 over 1. And the y-intercept this time is at 0, negative 4. So go over to my graph. And 0, 4, don't move, go up 4, that's my starting place. And then I go up 1 over 1. So I just use the slope to get to my second point. For the other graph, I go down, don't move, and then down negative 4, that's my starting place. And then the slope says go down 1 over 1. Make sure you go all the way over 1. And it looks like the solution is at negative 4, 0. Okay, same deal here. You're going to use your slope and your y-intercept. So that first guy, it's y equals 3x. And then the second guy, y equals negative x plus 12. So the slope on the first guy is 3, and we think that as 3 over 1, so go up 3 over 1. And it's y-intercept then is just 0, 0. So remember, you can always kind of cheat a little and put a plus 0 there if you wish. The second guy, its slope is negative 1, so that's down 1 over 1. And its starting place is at 12. So I'm going to go over to my graph here. I'm going to zoom in on that character, and I start at 0, 0. Go up 3 over 1. I hope that's right. If not, that's okay. I can change it, but it looks okay. And then 0, 12, and then I'm going down 1 over 1. Down 1 over 1. I hope that's right. Yay. Then I'm going to have to zoom in on this guy a little bit more to figure out that intercept. So it looks like it's at 3, 9. And you can check your equations by just plugging in 3, 9 if you're really unsure. And I'm just visually looking over and saying, okay, my point is 3, 9. So if I plug it into the first equation, I'll get 9 equals 3 times 3. So 9 is 9, so it works there. And then the second equation, I'll get 9 is negative 3 plus 12. So what am I doing? First, I plugged it into here, and then I'm plugging it into here. Okay. So 9 equals 9. So they both work. That has to be it. No questions. Okay, and then it's just more of the same. Use slope and intercept. Okay, until you get to these kind of questions. So the next set are on no solutions versus infinite solutions. So the no solution cases are the cases where you have parallel lines. In other words, they never hit each other, so there's no solutions. The infinite solutions case is when you have the same line. Both equations are the same line. So you go and graph one, and then you graph the other, and it's right on top. Okay, so they intersect basically everywhere, and so we'll say there's infinite solutions. Usually you could tell just by looking at the graph, but please do work. Like if I ask you on a test, you're going to have to graph both of these. So y equals 3x plus 7, and then y equals 3x minus 7. So they're in y equals mx plus b form, so I'm going to get the slope. That's going to be up 3 over 1. And then the starting place, the y-intercept, is 0, 7. The other guy, the slope is also 3. So up 3 over 1. And then the starting place, the y-intercept, is 0, negative 7. Okay. So just looking at the slope, I know that they're going to be parallel because the y-intercept isn't the same. So the slopes are the same, so they're parallel. It's not the same line because then the y-intercepts are different. Okay, so the first starting place is 0, 7. And then I go up 3 over 1. 1, 2, 3 over 1. And then the other line, 0, negative 7. And then up 1, 2, 3 over 1. And you can see that they are parallel. They don't hit each other, so you'll say there's no solutions. Here we have a vertical line involved in the scenario. It's got 14 is x plus y equals 2, and then x equals negative 3. So the first guy, you can just do intercepts, right? So for the x-intercept, let y be 0, so you get x is 2. And then for the y-intercept, let x be 0, so you get y is 2. And then this other guy is a vertical line, and if you need to, you can do the chart. So x is always negative 3, and then y is allowed to be whatever you want. Anyways, let's go over the graph it, go over the xy plane. So I got x is 2, and then y don't move. And then the other point, x is 0, y is 2. Okay. And then x is negative 3. So negative 3, negative 1, negative 3, 0. That's just a vertical line. So the solution should be at negative 3, 5. Just looking at the graph. Let's give it an extra negative there. I don't need that. This one is, okay, so 15, this must be the infinite solution case. And you're not always going to be able to tell that the lines are the same, right? I think that's the point of this exercise. So 3x minus 15y is 30. So I'll just do intercepts on both of them. So for the x-intercept, let y be 0. So x is 10. And then for the y-intercept, let x be 0. So negative 5y is 10. So y is negative 2. And then likewise over here, let y be 0. So you get 3x is 30. Divide both sides. X is 10. And then let x be 0. So you get negative 15y equals 30. So y is negative 2. So what you're seeing there is they both have the same intercepts. In other words, they're both the same line. And that's going to be the infinite solution case. So anyways, let's go ahead and plot both. You still have to plot both. You can't just plot one and say, well, the other one's right on top of it. No, the software is too literal to know that. So anyways, getting the intercepts on, x is 10. and then y is -2, so there's 1. And then you have to just go ahead and graph the same thing. There's infinite solutions, so you'll hit the infinite. There's all kinds of math speak there, all kinds of technical jargon along with the infinite solutions. If you look at the what's going on there with that set notation, so sometimes you remember, well, I guess maybe you don't remember yet, but back in the day, when you get your solutions, you put them in these. In the software, you have to put them in the little brackets. Instead of writing x is 5 as your solution, you put them in these brackets. Okay, that's kind of what they're doing here. It's just now our solutions are ordered pairs. So it's the set of all ordered pairs, x comma y, such that, and then you just put the equation of the line. You're either going to put such that x minus 5y is 10, or, and you don't have to write this out, I'm just explaining what that means. You'll write infinite solutions. Your answer is going to be infinite solutions. But I'm trying to explain why they write it out like this. So it's the set of all ordered pairs such that x minus 5y is 10, or it's the set of all ordered pairs xy such that 3x minus 15y is 30. Okay, either is correct, but you don't have to worry too much about that for now. It turns out they've kind of, in math, they've kind of tried to get rid of all English language, basically so you could put it into a computer and have the computer do the work for you without the problem of people's emotions getting in the way. And that's what a lot of those symbols are about, why they do it that way. It's just to get rid of human error. Number 16, we got two equations. So y is 2x minus 2, and then x minus 2y is -8. So the first guy is in slope-intercept form, so I'm going to get the slope is 2. It's the same as 2 over 1, so I'm going up 2 over 1. The starting place is 0, -2. And the other guy, I'm going to get the x and y intercepts. So for the x-intercept, let y be 0. So you get x is -8. And then for the x-intercept, or for the y-intercept, you let x be 0. So you get -2y is -8. So y is 4. And then we'll come over here and graph these characters. So 0, -2 is my starting place. And then I go up 2 over 1. And then the other point is -8, 0, and then 0, 4. So this is just the one solution case now. And it looks like we're at 4, 6. All right, more of the same. So use x-intercepts there. Maybe this one's a little odd, but this is an infinite solution if you don't see it. Anyways, we got 9x minus y equals 0, and then y equals 9x. So in the first guy, you're going to get two, the intercepts are both going to be 0, right? For the y-intercept, you let x, for the x-intercept, you let y be 0, so that would mean 9x is 0. Divide both sides by 9, you get x is 0. And then for the x-intercept, for the y-intercept, you let x equals 0. So you'll get 9 times 0 is 0, minus y is 0, minus y is 0, times -1 on both sides. So y is 0. So you need a third point. I'll just let x be 1. I have 9 times 1 minus y is 0. So 9 minus y is 0. Negative y equals -9, and then multiply both sides by -1. So you get y is 9. Okay. On the other side here, the slope is 9, which is the same as 9 over 1, which means go up 9 over 1. And then your starting place is 0, 0. Okay. They're actually the same line if you don't notice, but let's get in there and, yeah, I don't want that. Okay, so for the first guy, the x and y intercepts are at 0, 0. And then I found another point at 1, 9. Okay. The other guy starts at 0, 0, and then you go up 9 over 1. And lo and behold, it's the same line. Okay. So in this case, there's infinite solutions. It's a set of all points that are on that line. So over here, you would just write infinite solutions for your answer. Of course, you have to graph it on my test, but infinite solutions. Okay, number 19 is just a horizontal and vertical line, and you find where those guys intersect. This is 2 vertical lines, so there should be no solutions. So we can come over here. X is 2, so that's just x is always 2, and the y-coordinate varies. X is -1, and the y-coordinate varies. They're parallel, so there's no solutions. Okay, it'll be the same deal here, but these guys are horizontal lines. Okay, so in these problems, what you're doing is you're not graphing it. You're just kind of looking at the slope and the y-intercept and making your determination based off that. So okay, so 22, my pen upside down. We got 22. Three sevenths x minus 3, and then y equals 3/7 x minus 4. So the slope of this first line is 3/7. 3/7. Okay. And then the y-intercept of this line is at -3. I think they just want to put -3 in here though. And then do the same thing for the other line. So here the slope is 3/7, and then the y-intercept is at -4. So I put 3/7 in here. And then this is -4. And then from the information, you determine how many solutions there are. So these are parallel lines with different intercepts. Okay, if they had the same intercept, they'd be the same line, but they're not. They're just parallel, so there's no solutions. Okay, so the picture here, you know, 1, 2, 3, 4. You would have these 2 lines like this and like this. They don't intersect. Okay. This is the same deal, except one equation is kind of written funky. So we have number 23, y is -9 x plus 8, and then 2x minus y is -8. Okay, so the slope in the first guy is -9, and that's y-intercept is 0, 8. For the second line, you can't just read off the slope, right? It's one of those ones where we're going to have to move things around first. I'm going to multiply both sides by a -1. So it's positive y equals, and then here I'm distributing by -1. So the slope here will be 2, and the y-intercept is at 0, 8. Okay. All right, so zip through, give them the information they want. So 2, and 8. Okay, so there's 3 choices. 1, infinite or no solutions. For them to be infinite or no solutions, the slopes would have to be the same. So And it must be that there's just one solution. You can even see what the solution is at 0.8. More of the same malarkey. So you have to solve that to get the slope. Sure, let's try this one. So I got 5x minus y is 15, and then x equals y over 5 plus 3. So for the first guy, I'm going to move the 5x over. So you get negative y is negative 5x plus 15. Then I'll multiply both sides by negative 1. So on the left, I get negative negative is positive. On the right, distribute the negatives. So I get 5x minus 15. So the slope is 5, and the y-intercept is at negative 15. The second guy has a fraction, so what I'm going to do is multiply both sides by the denominator of that fraction. So I get 5x on the left and on the right. When you distribute, you'll have 5 times y over 5. That'll be 5y over 5, which will just be y, plus 5 times 3 is 15. And then you'll get y, move the 15 over, flip-flop the sides. Y is 5x minus 15. They're the same line, okay? So they'll both have the same slope, same intercept, and there'll be infinite solutions. Okay? So this will be 5. This will be negative 15. This will be 5. This will be negative 15. Okay, so infinite solutions. So if they had the same slopes but different intercepts, it would be no solutions. When they have the same slopes and the same intercepts or the same lines, so that'll be infinite solutions. Okay, more of the same beeswax. And then finally a story problem. So these story problems become more interesting. You'll see supply and demand problems where you're trying to get the supply to equal the demand, so you're not buying too many items, and then you're left with a surplus, which isn't always helpful. But in this problem, what you're doing is comparing two rental companies and trying to figure out how many miles do I have to drive so that both rental companies cost the same, basically. Well, they're going to walk you through and like ask you for information and then to interpret the information. So there's two companies. Let's just call them 1A, 1B. So 26 company A charges 35 cents a mile and $41 a day. So you'll say, you always want to define your variables. So X, let's say that's the cost per mile. And then Y is the cost, the total cost for the day. So the cost for the day, Y, will equal the variable amount, 35 cents times how many miles you drive, and then plus the cost, the down payment of $41 for the day. Right. So it says a rental company charges $41 a day plus the 35 cents per mile to rent a moving truck. The total cost Y for a day's rental if X miles are driven, and then they give you that equation, so you don't have to really think about it. The other company charges 45 cents a mile, so 0.45x, and then they want $35 down. Answer parts A through B. So determine from the graph the x-coordinate of the intersection of the 2 points. So you say the word of a lot in math. Anyways, it looks like it's about 60, 60. So the x-intercept looks like it's at 60. So part A, the x-coordinate of the x-intercept is 60. So we'll just write 60. Okay. Describe what the x-coordinate means. Well, see, what you're doing is equating these two. You're graphing these two equations and finding where they hit each other. And you know, that's that coordinate where they hit each other is going to be where the cost is the same for driving X miles. Okay, so basically you're saying it's when you drive 60 miles, both car companies will charge you the same amount. Okay, so you just scroll down. Both car companies charge $60 for the miles driven. Oh crap, I didn't read it. The maximum amount, no, both companies charge $60 for the same, I guess that's what they want. Both companies charge the same for 60 miles. Oh, sorry, so 60x is the cost per mile. No, x is the number of miles driven. So this is the number of miles driven. Okay, so for 60 miles driven, both companies charge the same. Yeah, so both companies charge the same for 60 miles driven. Okay, what is a reasonable guess for your y coordinate? So I'd say, looking at the graph, it looks like it's about 60, and the closest to 60 maybe is 63. It's definitely above 60, so it's not 57. Okay. Substitute the x-coordinate of the intersection into each equation to find the corresponding y-coordinate. What does this mean in practical terms? So I'll go y equals 0.35 times 63 plus 41, and then y equals 0.45 times 63 plus 41. Okay, so get the calculator working. 0.35 times 63 plus 41, 63.05. And then the other guy, whoops, this one's supposed to be 35, sorry. So 63.35. So it says, oh, I was supposed to put 60 and not 63. Oh. Sorry about that. So I got 0.35 times 60 plus 41. That's 62. And 0.45 times 60 plus 35. Oh, they're both 62. Okay, great. Substitute. So this is 62. And this time this is cost, right? It's going to cost 62 bones for either company to drive 60 miles. Yeah. So both companies charge $62 for 60 miles driven. How close was this to my estimate from Part B? It's close, right? It's very close. It's only off by 1. So my estimate from Part B was 63. And I think that'll do it. So, okay, that'll do it for this section. As usual, thank you for watching, and I will see you next time.